So I'm going to pass on over to Chris, who's going to talk about how we use STACK to address some of these types of common errors.
Yeah, thanks. Well, I have to confess to everyone that I hadn't really been involved in a lot of the design of the first part of the workshop, and I hadn't seen those questions or the quiz before. And I really found working through the quiz with a couple of other people quite an engaging activity, which I'm going to think about adding to my repertoire of activities that we can do with students, even if they're just filling in text questions. I think that actually as an activity was kind of engaging. So thank you folks for setting that up. Right, so my job was to be a bit more practical and think about how we might do this in STACK, okay? So I'm just going to go through a few features of STACK that are probably not obvious the first time you use it. And the way we're going to do this is I'm going to show you a couple of things, and then we're going to encourage you to go into groups to do this yourselves on the question authoring section, right? So what we've set up, and I will share my screen, I'll just share my whole screen, is we have set up what do students answer. And if we go over to, where is it? If we go to the question authoring section, I'm getting all lost now, sorry. No, question authoring. So if we go to courses, and you go to authoring workshops down here, we've got this authoring workshops, and you can all enroll as teachers in here. So again, we'll figure that out in a second. And here is the student errors workshop, right? So what we have to do is go to question bank questions, which is down here, question bank questions. And under the category addressing common student errors, which is where we are today, there's one question in here. And I'm just going to duplicate that question. And so I can find it again, I am going to remove copy and put in CJS, so I know it's my version. So I have made a duplicate of that question. I'm just going to save that and continue editing before I do anything else. So that means I'm not going to mess up anybody else's work. So let's just look at that question. This is the area between the x-axis and the curve over that interval. Agreed? So that was one of the questions that came up in the workshop that we've done. So let's look at how this question has been authored so far. There is one potential response tree, and it is just checking algebraic equivalence of the student's answer with the correct answer. That's the kind of modal way to start, isn't it? Right, and TA1 is just blah, 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 whatever it is there. Okay. Right, so let's go into the question test and deployed variants. So we haven't deployed any variants yet. That's fair enough. We haven't added any question tests yet. That's fair enough. But down here, you may not have seen this yet. At the bottom of the page, right at the bottom of the page, there is this button, Send to CAS. Okay. And if you click on that button, Send to CAS, then you come into this chat page. And what the chat page does is it allows you to play around with the question. Okay. So if we just type in some CAS text here and then send that to the CAS, right, it will evaluate that CAS text, just like you're used to doing when you're seeing the question, but you can just do this live. So in particular, we could do things like, so what was one of the, I'm going to just stop sharing a second. What was one of the common errors for that question? Can someone suggest, just put their hand up and suggest what we might do for that question?
I think possibly one of the errors was just taking the integral and forgetting to consider kind of negative area under the axis.
Okay, absolutely, right. So So let's go back in here and so we'll call it W for wrong answer 1 would be the integral of, now we better do it in terms of the question variables, so it's curve, isn't it? And the right hand side of the curve is func, so let's do it in terms of the random variables. Func from, okay, and we've got 0 to 2 pi, and that's hardwired in. So the variable is hardwired as x, so we just do x 0, 2 times pi, right? So now if we just look at wrong answer 1, right, that's 0. Or if we don't do wrong answer 2, or I'll call it, just order it in a sensible order, wrong answer 0, then maybe we just do the indefinite integral. So we've got two things here, right? We've got that function and we've got the 0, right? So this screen allows you to mess about with things without the commitment of saving the question or going around that, right? You can see what's going on. So what I'm going to do now is I'm going to copy those additional question variables back. Now this is my clean question, so I can copy them back up to here, and I'm going to put some semicolons on all my question variables just to make sure we can. And now I've got these additional question variables that I can use anywhere in the question. Yeah, so let's just save that. And now I'm going to scroll down to the potential response tree, and let's look at that potential response tree. So if we've got, I'm just going to have to make this a bit smaller. Sorry, that's a bit smaller, but I want to get this on the width of my screen. So we've got this correct answer. So now let's add another node in here. And what we're going to do is we are going to, instead of algebraic, okay, so the algebraic equivalence of the student's answer with the correct answer, let's imagine they've got that, that's wrong. We know it's wrong. They've come down this branch. We're now going to go to another node. And what we're going to do is we're going to check algebraic equivalence of answer 1 with W0. So W0 was the variable, which is that unevaluated integral, isn't it? Now, I don't think algebraic equivalence is really the right test here because they've done an unevaluated integral, so we should do an unevaluated integral as well and use the integral test. And now when we save and change that, come back in here. Oh, I've got to do an integral live on a, right, so it's going to be -2 times cos of x plus c, right? Okay. Right. Now, if you notice here, this doesn't make any sense because we don't want that standard feedback that test provides. So we come back to the potential response tree and we make that test quiet, right? So it doesn't give the standard feedback. And if that test is correct, it is you appear to have just integrated instead of finding that area, right? And in fact, I think that should be function in any case. So that's going to be -4 times cos of x plus c. What did I do wrong there? Right. So let's go into here, add a test case. So we should be testing all these test cases. So what I've done is I have created a test case, W0.
I think potentially you called it WA0, Chris.
Oh, of course I did. Thank you, Malta. I'm tired on a Friday afternoon. Right. And obviously that test is going to be, where are we?
Chris, you also have the wrong name in the potential response tree.
Why is that?
There is you've written W0 instead of WA0 in the test.
Ah, okay. In here? Right, good. Okay, at last. That's embarrassing. Right, so I got there at last. So that's how the kind of mechanism of how you go about adding in these tests, right? So what we do is we identify a common misconception. We then go back, and from the potential response tree, we can build up this tree where we add tests for those specific errors. And then having identified that error, that's not the right answer, so we often want this to be a quiet test. We might be able to give some feedback, and we can adjust the score and the penalty depending on what we actually want, having identified that error, right? So one of the traps here is, having identified the error, you then think that's the correct answer and might give that score of 1, even though you know that's an error that arises from a common mistake. Everyone will have a chance to do that in a moment and think about some other common errors. But what I want to do before we do that is go back into this, our actual workshop group here, because we have one of the earlier questions, the dot product question, okay? And again, if we go through the same sort of process here, we've got this dot product question. Here are all the random versions. And let's send this to Cass, okay? Let's send this to Cass. And what we're going to do now is we're going to add in, I'm going to get, so I'm going to get rid of the Cass text, because by default that will be the work solution. This screen is really designed to help people write the work solution. Now, what we've got is we've got VEC1, so WA0. So certainly one of the things that we came up with in our workshop was that we would, instead of multiplying together the entries in the vector, we would add up corresponding entries in the vector, right? So one of the problems is when you're trying to construct an answer that arises from a student's common mistake, is that we've got to go through that process with the computer algebra system and do what the student has done to create that common mistake. So we do need to learn a bit of computer algebra code to do that, okay? So in order to construct that in this case, what we need to do is we need this function called zipWidth, right? And what we can do with zipWidth, we take an arbitrary operator and two lists. VEC1, VEC. Right, I'm just going to do this as a really simple example. 1, 2, 3, and then 3, 4, 5, right? And I'm going to turn simplification off, and I'm going to show you what this does. WA0. Okay, so what this function zipWidth does is it takes two lists and it takes an operator, right? So we've got list 1 and we've got list 2 and we've got our arbitrary operator, whatever that is, and it takes the two lists and it zips it together. Okay, so that's the idea with this, right? That's what it does. It's an extremely useful function. So that's the point of this. So, and because I've turned simplification off, we can actually, we've zipped them together, but we haven't done the simplification. So if I now simplify that, it will be the sums, but we don't want these lists. We want the actual random lists, VEC1 and VEC2. Right. Okay, VEC1 and VEC2, and then we simplify that again, right? And that will be whatever we've got in our random question, like that. Okay, now we need to do something else. Because WA2, W1 will be, that was one of the distractors that our group found, but the other distractor was when we added up the result of that. It wasn't just pairwise additions, it was then pairwise additions and the sum of those. So how do we sum a list? Okay. So in Maxima, I'm going to turn, this is a desktop Maxima, and I encourage you to use desktop Maxima for playing around with this, okay? So we've got list, I've just turned simplification off. Here's a list of 3 things. And if we look inside the actual underlying expression, there is a function, mlist, which constructs the list. Now that's the internal Maxima representation. If we ask what is the operator, it is the list constructor function. So one way to change a list into a set by the set constructor function to that list. And now we would get a set, and that would give us a set. But we can equally apply the function plus to that list, and that will add up the list, right? So again, with a little bit of Maxima knowledge, what we can then do up here is we can apply plus to WA0. And again, I'm going to put some things in here, semicolons, and now WA1 will be the sum of that. So what I'm going to do here is just copy those useful expressions, go back to my question, add them into the question variables, okay? Right. And in the potential response tree, if this, add another node, I'm going through this quickly a second time, just so you can see what we can do. If the students have got that wrong, and we go to that node, and if ans1, it is ans1, ans1 is algebraically equivalent to WA1, you need to apply plus to the zip with times V1, V2, you look like you have, right, this is clearly going to be highly intelligible feedback to our students. Right, something like that. Okay. And now, if we go in here, right, and we add in a question test, oh, sorry. We add in a question test. Answer 1 should be TA1, shouldn't it? That should be 1, 0, TA1. So we create that test case. And now let's create, what did I do wrong?
I think TA1 should just go off on the first branch. The first branch.
Yeah, it should. Okay. I got that wrong there, didn't I? I just didn't. I'm not using the cheating button. That's the problem. Thanks, Malta. Right, so now let's do WA0. I'll use the cheating button and hope that that should be the true branch.
I think that was WA1 you did for that. WA0 was the one that keeps it in
yeah.
Keeps it as a list.
WA1. So now we've got that test case. And now what we need to do is we need to run all the tests on all the test cases. And this, I hope, will illustrate why right, so we can see now this is the advantage of testing questions carefully. We've got all our random versions working, but there's one here where the random numbers just happen to fail that test case. If we look at this, on this random version, the correct answer is indistinguishable from an answer that arises from a common mistake, right? So the advantage of testing this, like this with these test cases and pre-deployed variants, you know, this really illustrates the value of pre-testing all the questions. I have to confess, I'm hugely grateful for Malta for setting this up for me. This is all his work, right? To come up with a question and a test case like this. So thank you for doing that. How on earth do we come up with these? You know, I would say, one, I predict 1 or 2 things that I know from my experienced students will do. I don't have to come up with 4 things like you would with a multiple choice question. So that's a big advantage of STACK. And then the second thing I often do is look at real student data. So I'll show you how to do that as the last thing that I'm going to do. So what I've done is I have taken student data from one of our real courses in Edinburgh, and it is in the workshops, and if I go up one level, and this quiz is in here. This is one of our, there are 550 attempts at this, and I have to do something like click on the attempts and then all users who've attempted the quiz, because these are anonymous people. So I've made these anonymous, okay? So if we just review this anonymous user and have a quick look at what they've done. So this was a real quiz. I think this is one of our engineering maths courses. Which of these functions are even? Find the equation line. So let's actually go back to this question. Right. And down here are the question tests, blah, blah, blah. And if we go to the basic usage report, this is fairly new, but if you click on this, what it will do is it gives you all the attempts at this question, regardless of which quiz the question was in, right? So there were 541 attempts at this. And this is the, let's just look at one random variant, okay? So these are all the things the student typed in. Now, some of these, some of these differ in a trivial way, but this script just shows you what they typed, okay? That's all this does, right? So these are all considered different. And there were 2 people that got plus instead of minus, so that might be a common thing. But look here, this is just an invalid thing, right? So even though on this question, we have, even though on this question, we've helpfully put y equals to discourage students from doing that, students are still putting y equals as their answer, right? And that will trigger a not equation note. So if we scroll up to the top and look at the notes, regardless of which variant was used, 2% of students over all the random variants have triggered that note. So 2% of students are still typing in y equals, even though we can see that they don't need to from the question, right? I mean, even when you do your best to encourage the students to type something in a sensible way, they just still do that. So what we could then do is go back and test for that property on the basis of having seen it in real student data. Now, in this case, I would probably reject that as invalid and not wrong, rather than putting an extra node in the potential response tree. But my point is, by looking at what students are really doing, I could spend all afternoon second guessing what they might do on this question. And I might spend ages writing a complicated potential response tree that never ever gets fired because students in practice just don't make that mistake, right? So it is much more pragmatic if you're in this for the long game to look at what students do and improve it for the next year, right? We've got 550 students. You can wait for the first 50 students to do the quiz and then have a quick look to make up. No, so Sam, no PRTs in year 1? Well, no, I mean, I guess something that's common, right? I mean, I can guess 1 or 2 common things, so I'll certainly put those in, and normally they're useful. I'm just not going to have to come up with 5 things, and I'm not going to agonize over every last thing and do it's just a cost benefit, right? It's total cost benefit. Okay, any questions about that? So I think what would be good is if people have a go at actually trying to go into the authoring site and add a potential response node with 1 common mistake to that sample question, and we'll take it from there. Thing I didn't say before, if you've got a quiz that's halfway through, or you go to a quiz after it's finished, and so sometimes a student will say, I did this and I didn't get any credit, that's unfair, and I'll kind of agree with them and I'll put in a test and give them some partial credit. Nothing will happen until you regrade the entire quiz, okay? Just because you change the question won't change any previous attempts at that question. You actually have to go into the quiz and regrade. Does that make sense? Right? And again, the basic test use report won't update until you regrade. So please just think about that. And the great thing is you can do a dry run regrade that won't actually regrade everything. So you can confirm that that's what you're doing. And since the database has no undo, it's a very good idea if you're contemplating some complicated changes to the question to copy the question somewhere else, make sure your changes work somewhere else, and then redo them on the live question, right? Does that make sense? It's a pain in the arse workflow, but bitter experience suggests it's worth that effort. Right, and the last thing, just a bit of fun on a Friday afternoon. I'm sure that no doubt many of you will have noticed this page and remember it from reading the docs, but there is actually a page called Buggy Rules in here. I have already created some Maxima functions. There's a function called Buggy Pow, which will do this for you. Right? There are some things which are kind of hard for you to work out how to get the computer algebra system to do. So there are some inbuilt functions which will do things like that for you, right? So have a look at the Buggy Rules page, and I'm more than happy to add crazy rules in here if you want. You know, there are already a couple. The median of 2 fractions is naively adding 2 fractions. Yeah, if you want some fun over the weekend, this turns out to not always give you the wrong answer to a problem. It's not the sum of 2 fractions, but the median of 2 fractions sometimes turns out to give the right answer to some problems, which is just craziness. Anyway, that's enough for me.
Okay, thanks very much, Chris. There's just 2 things I wanted to say in the kind of final minute. So first of all, Ian's pointed out that from the previous workshops, there's a report that's being produced from kind of comments that have come from participants. He's going to add some comments from what we've been discussing today to that, and we're going to make that available to everyone who's participated. So look out for that. I guess I'll send that around to everyone by email when that's ready. Part of that as well is I have got in touch with Igor to ask if it's okay for people to use these questions, because people seem to like them. So I'll let you know, I'll update you on that once I know. And finally, just to show you on the course webpage, I've just made available down at the bottom here a feedback survey. So we'd really appreciate it if you could take a minute just to leave us some feedback on the workshop. If we're going to run something like this in the future, what might we do differently? It'll just be helpful for us to know as well if you've got other ideas for things that you'd like future sessions on. So very much appreciate if you could do that, and thank you all for coming along. And of course, thanks to Ian and Chris for showing off what STACK can do and telling us about the theory.
And thank you to George, and thank you to Multi for organising and setting everything up so brilliantly.
Yes.